the next session, let me introduce Dasun Theekshana, who is a third-year data science undergraduate who is going to brief us about the introduction to frameworks. Over to you, Dasunaya.
Thank you very much, Gahana. So, very good evening to everyone who has been joined in. So, welcome to ITP Guide 3.0. So, I'm Dasun Theekshana, and I'm currently a third-year data science undergraduate at SLIIT, and I'm also a member of the MS Club of SLIIT. So, in today's session, I'll be talking about, I'll be introducing what frameworks are and what are the uses of frameworks and all that, and as well, and finally, I'll be also talking about differences between SQL and NoSQL as well. So yeah, when it comes to contents of today's session, so these are what I'll be talking about. Firstly, I'll be talking about what are frameworks, and then why we use frameworks, and differences between libraries and frameworks, and technology stacks I'll be also talking about as well. And then finally, I'll be talking about SQL versus NoSQL and the differences between them. Okay, so without further ado, let's start our session. So yeah, first of all, what is a framework? As you can see on the screen, it's very simple definition. It's basically a structure for developing software applications, and it serves as foundation on which developers can build programs for a specific platform. So since you're moving on to the second semester, I'm pretty sure that you are familiar with coding. I think you have done the IWT module and the OOP module as well. You're familiar with Java coding and I think JavaScript coding as well. So you have been exposed to a little bit of programming and software development. So as you probably know by now, software development and coding is not that much of an easy process. It's a little bit complicated. It's a little bit of a hard process. It's not just writing some code, lines of code on a code editor. It has much more than that. You'll have to test your code. You have to debug your code, and there'll be a lot of errors as well. And you'll be concerned with security and other factors as well. So as you can see, coding is if you take a very large scale than what you did in IWT, in large scale web development, it gets much complex as well. So basically, coding is hard, basically. But imagine that if you instead of you start coding from scratch, that you had instead of start coding from scratch from the beginning itself, that if you had this pre-built framework or a structure or a layout of code through which you can begin starting your code, start coding. That would be much easier for you, right? You will be saving a lot of time. So that is what a framework basically is. It is basically a pre-built structure or a layout of programming or code, which enables you to code more efficiently and build web applications much more efficiently. So yeah, and coming to the third point as well, it's typically associated with a specific programming language. So since you're familiar with Java, I'm probably sure that you've heard of the framework Spring Spring Boot. So what Spring Boot basically is, it's a Java-based framework, and what it does it takes the most of the work out of configuring and building Java applications. That's what I meant by it's associated with a specific programming language. And another thing I have to say about frameworks is it lets you focus on high-level functionality of web applications that you build. This is the reason for this is because any low-level functionality of the website is usually taken care of by the framework itself. So you can focus on your high-level functionality and features of your web application. So moving on to give you a much more better understanding about what frameworks are, basically, I will be giving you a simple analogy. So imagine that you're a builder and that you're building a house, right? So to build a house from scratch, from the beginning, first thing you have to do is you have to lay the foundations, and then you have to build the columns and lay the groundwork and all that, and build the walls, and then you have to come to other things such as building the roof, furnishing, and all that, painting, and all that. So if you're doing this on large, if you're building a couple of houses, if you're building a lot of houses, this would take a lot of time, right? It obviously takes a lot of time. But imagine that you have this pre-built structure of the house, where the ground and the foundations and the columns and the walls and the structure of the roof has already been made, a ready-made structure basically. What this would do is it would largely save your time and make the whole construction process much more easier and much more efficient, right? So since you have this structure now, then you can focus on other things of the house, the furnishing, the finishing of the tiles, the electricity, and other things, the finishing of the house basically. So that's what a framework does basically in the context of web applications as well. It gives you this specific structure on which you can build web applications, making software development process much more efficient and faster. So moving on. So why do we use frameworks? Okay, first point is saving time, as I mentioned earlier. So since you have this pre-built structure on which you can start coding on, it saves a lot of time, and the developer doesn't have to worry about a lot of functions that are usually have to be taken care of in the process of coding, such as session handling, error handling, and authentication logic, and all those things. So since all of these functions have been taken care of by the framework itself, it saves you a lot of time, which makes the whole development process much easier. And the next step, you have avoiding duplicate and repetitive code. So if you're building a web application from scratch, you will be obviously writing a lot of redundant code over and over and over again. But since you have this consistent coding approach, pre-built framework, you could say pre-built structure or the layout, it gives you the ability to avoid writing duplicate and repetitive code over and over again. It avoids redundancy in code basically. And the next up, it gives you more secure code in your web applications. Now, obviously, code security or data security is a really big concern when in the whole software development process. So, since frameworks takes care of this code security, what it does is it gives you a lot of space, and it gives you basically what it does is it gives you much more secure code. This is one more burden out of your head. This once again makes the whole process of coding much more efficient. And then you have simpler testing and debugging. Once again, because of this consistent coding approach, testing and debugging process is much more easier compared with without a framework. And another thing you have to consider is the scalability and the reusability. And reusability is quite obvious because you have this set framework. You can once again reuse your that chunks of code or throughout your web applications much more easily. And then, last but not least, it is easier to deploy as well. And then the maintenance once again is much more easier because the application follows once again a consistent coding approach. It makes it easier to understand the code, and overall it helps in maintaining the code much more easily. And moving on. So the difference between frameworks and libraries. I'm pretty sure most of you don't know the term libraries, and most of you might know the term libraries. And there's this misconception and confusion between the terms libraries and frameworks. Some people think it's some people confuse them one another. So before talking about the difference between frameworks and libraries, I'll give you the definition of what a library basically is. So it's a predefined collection of reusable methods and functions that are called to form specific well-defined operations. And to make it much more concise, what that basically means it's a collection of reusable code basically developed by developers to make the coding process easy, much like frameworks. But there is an obvious difference between these two. So the key difference between these two is when you call a library, you are in control. But with the framework, control is inverted. Framework calls you. Now, what I mean by it calls you, it doesn't call you, not literally, but figuratively. What I mean by calls you is it calls your code. So when you call when you code, you can call a library through your code. But on the other hand, if in frameworks, a framework calls your code. So that's the biggest difference. And for this term, this the model of this is basically called the inversion of control. To make it much more simpler, what I mean is when it comes to libraries, there's much more freedom in using all these methods and functions within the library, and when it comes to framework, there's a much more stricter and much control by the framework itself when using the code. So basically, you can say that libraries offer much more freedom when it comes to coding in comparison with frameworks. So okay, to give you a much more better understanding of what libraries and frameworks are, you can refer to this particular diagram, and it shows you actually another feature between difference and similarity between library and framework. So we could say that framework is a collection of libraries in a sense, as you can see here. Frameworks itself contains libraries as well, and as I mentioned earlier, so you can call a library through your code, and on the other hand, frameworks calls your code. So that's the biggest difference that you can see between a library and framework. And last but not least, the framework is much more complex, as it seems, and it is has a lot more behavior and control and stricter structure built in compared with a library. And all the control flow is already in the framework as well. So now I'll be coming to a bit of examples for both of these libraries and frameworks. So as you can see on the left, you have a bit of examples for very popular development libraries. You have React.js, you have Socket.io, you have Dojo Toolkit, jQuery, Backbone.js. These are some of the quite popular front-end development libraries actually using these days. And on the right, you have very popular frameworks, a couple of frameworks. You have Vue.js, you have AngularJS, you have Svelte. These are front-end frameworks. And to the bottom right, you can see Django, Laravel, and Express, which are basically backend frameworks. I'll come to much more about frameworks in a while when I talk about tech stacks. So yeah, next thing I'll be talking about is a technology stack. So a technology stack is basically, as you can see on the screen, a collection of software, services, programming languages, and frameworks that is used to develop, maintain, or to maintain web or mobile applications. So as you can see on screen, there's a lot of technologies out there that you can use or a developer can use in developing a web application. But obviously, you can't all use all of these technologies at once. You'll have to make compromises. And even though you can use all of these technologies, it won't match the requirements of the website you will be building. So you'll have to choose your stack based on the requirements of the website you're building. So that's what technology stack basically means. You have to choose a couple of technologies based on your requirements. And this is what you call a technology stack, a couple of technologies which you use to build web applications. So a technology stack basically consists of two types of technologies. And firstly, front-end technologies, and then backend technologies. I'm pretty sure with Shivani's session, you understood what front-end and backend mean. So front-end technology is also called client-side technology. And as Shivani mentioned, front-end is basically what users see and interact within the website, in a website or web application. For example, if you go to a website, the things you see and you interact with, buttons and all that, that is what you basically call the front end. And usually a front end is developed, it consists of basically HTML, CSS, JavaScript, and you can also use other frameworks as well. And when it comes to backend technologies, it's also called server-side technologies as well. It is basically what happens behind the scenes, the functioning of the application, server side, the data and all that. That is included in the backend technologies. So backend technologies basically consists of web frameworks, programming languages, servers, databases, and operating systems. And if you take a look at the diagram on the screen, you could see an overview of the simple tech stack. You have front end Even though the backend and database is taken as two different entities in this particular diagram, usually it is taken as a backend as a whole. So keep that in mind. And to give you a bit of a more understanding, you have this diagram right here. And on the left, you can see technologies, stacked on top of each other. That's why it's basically called a stack. You have the operating system, web server, database, programming language, and web frameworks and libraries on the server side, which basically means the backend. And then on the right side, you can see the client side technologies on the front end. Use the HTML, CSS, and JavaScript, and other frameworks as well. So yeah, that is what a technology stack basically means. And then I'll come to some examples on some popular tech stacks, frameworks, and libraries. I've mentioned that there are some couple of popular tech stacks like Bean, Mern, and Maven. Although you can choose, custom tech stack based on your requirements. So yeah, talking about frameworks and libraries, you have Vue.js, Angular, React, Next.js, Svelte, Flutter, and Backbone.js. Here, the Flutter is quite different from the rest. All the others are JavaScript-based frameworks and libraries, while Flutter is based on a programming language called Dart, and it's cross-platform as well. And then you have backend technologies. You have Django, which is a Python-based framework. I have Flask, which is also a Python-based framework. Then you have Laravel, which is the PHP-based framework. And then you have ASP.NET Core, which is developed by Microsoft. It uses .NET languages. There is C# and Visual Basic. Then you have Ruby on Rails, which uses a programming language called Ruby. Then you have Spring Boot, as I mentioned earlier, using which is a Java-based framework. You have Node.js, which is not exactly a framework. It's called a runtime environment. What Node.js basically does is it allows you to run JavaScript outside of the web browser. So that's what Node.js does. It's a runtime environment. And Express.js is once again a backend framework which works alongside with Node.js and it's used for API routing. And as I mentioned earlier, there are a couple of popular stacks that are used in the industry as conventions. You have the Mern stack, Mean stack, Maven, and LAMP. I'll come to the explanation and what Mern and Mean and Maven and LAMP means in the next slide. So yeah, first of all, you have the Mean stack on the top left corner. And as I mentioned earlier, a technology stack is a collection of technologies that you use in your web development process. And as you can see, the first one, the M in the Mean stack stands for MongoDB, which is database tool which is used. And you have Express, which is the backend framework that you use in the Mean stack. And you have AngularJS, which is the front-end framework. And finally, the Node.js, that stands for N, which is the backend runtime environment. And if you take a look at the bottom left corner, once again, it's the Mern stack. Once again, the only difference here is that instead of AngularJS for the front end, here a library called React.js is used. It's a very popular library, front-end library. So that's the difference between Mean and Mern. And on the top right, you can see the Maven stack. And here the difference is instead of Angular in the Mean stack or React in the Mern stack, here Vue.js is used, Vue.js framework. So yeah, these are the differences between Mean, Mern, and Maven. And then you have LAMP, which is quite an old school, not particularly old school. It's been there for a long time. You could call it an OG framework. It has been around since the 90s in the early days of web development. So LAMP framework is based on Linux environment. So L in LAMP stands for Linux, which is the operating system which is run, and A stands for Apache, which is basically your web server, and M here stands for MySQL, which is the database system. I'm pretty sure you're familiar with it. And once again, P stands for PHP. Pretty sure you've used that in your past modules as well. So yeah, these are some of the most popular, full stacks. And then we come to a quite important part, which is choosing a technology stack, which is quite important for you as students who's going to do the ITP module. There's basically a couple of important factors that you have to consider. So I've sort of listed them out based on priority, not really based on priority, but yeah, some of the most important things basically. Yeah. So on the top of the list is actually requirements and objectives of the project. So this is the most important thing that you have to consider in choosing technology stack, frameworks, or libraries for your ITP project, basically. So as I mentioned earlier, technologies you have to use differs according to the requirements of what you're building. So, for example, if you're building a hotel management system, the technology stack would be quite different from when you're building something else for like a real-time messaging system or something like that. Then you have to use quite a kind of different technologies and frameworks. That's what I meant by requirements and objectives of the project. What you are planning to build, you have to choose your web frameworks and technologies based on what you're planning to build, because some frameworks have functionalities which others don't offer, and you have to choose your technologies or frameworks based on what kind of functionalities they offer that helps you in your requirements of the project. And then you have scalability. So scalability, what scalability basically means is, the ability, or you can say the, increasing or decreasing in performance or the capacity of your web application. In case if you want to grow your web application to satisfy increasing demand or increasing users and increasing data. So you have to consider this as well, because some frameworks and libraries facilitate scalability much more efficiently compared with others. So you have to consider if scalability is one of your concerns when building a web application for your ITP project. And then you have skills and knowledge of the development team. So that is quite important as well. So development team in your case, in your context, is the group of 8 members who are doing the ITP project. Now, since you have been in SLIIT for a while, since you have done a lot of modules which have covered a little bit of web development, you might be familiar with a lot of technologies such as JavaScript, once again Java as well, and you have used database technologies such as MySQL. I'm pretty sure. So you can use this as a starting point when choosing a technology stack. So there's a lot of JavaScript-based frameworks and libraries out there. You could use that skill set of yours to your advantage. If you're using Java as well, you can start there as well. So I'm not being biased towards Java and JavaScript-based frameworks as well. So if you're obviously have used other frameworks, so Python-based frameworks, PHP-based frameworks like Django or Laravel, you could use that as well. But be mindful that you're working under a deadline, which I'm coming to next. So choose your tech stack, based on the skill set and the knowledge of members. So I wouldn't, I'm not discouraging you to not learn from the beginning, learn a new technology from the beginning. So that's okay as well. But keep in mind that you're working on a deadline. So manage your time basically, and use your skills for your advantage. And the next time is, as I mentioned earlier, time to market, which basically means the time it would take for you to build and deliver a complete web application. In your case, the ITP project. So this is quite important as well. Since you have less than 5 months, time is of great concern for you guys. So you'll have to consider the what kind of framework that you should be using for your ITP project, because some web frameworks are much more efficient and perform much more well, especially when it comes to rapid development and all that. So consider that as well when you're choosing your frameworks and technologies for your ITP project. And then the user experience. Here, I don't necessarily this only mean the front-end technologies, the front-end user experience. Even the back-end technologies, the performance of the database tool you're using and backend frameworks you're using and runtime environments sort of contributes to the user experience as well, because the performance of that matters to some extent to the user experience and the efficiency and the fluidity of your web application as well. So you have to consider performance on user experience that you are going to deliver through your web application when selecting a framework. And then you have development cost. So most of the web frameworks out there and web libraries and frameworks out there are open source, which basically means they are readily available to use. But in some cases, actually, you'll have to buy licenses or subscriptions to use some of the services, such as web infrastructure, server hosting, and all that. So keep that in mind as well as a factor when you're choosing technologies. And obviously security as well. Security is a great concern as well. Keep that in mind as well. And then community and documentation. And the last point is quite similar to community and documentation as well. I'll come to that. So community basically means is the people who are using the developers who are using the particular technology that you're considering. So let's take for example, let's take React.js. It's very popular front-end library. So there's a lot of community behind it. There's a lot of developers using React.js. So if you come across a problem, it would be much easier for you to find answers for that particular problem because there's a huge community behind React.js. So if you go to Stack Overflow and ask your query, you will most probably be getting an answer quite quickly compared with a framework which has a very small community. So that is what I meant by community. It's quite an important factor as well. And then documentation. So what I meant by documentation is how well that technology or a framework or the library is being documented in the website or in the documentation. So if the web framework or the library is quite well documented, it would be much easier for you to understand and learn that particular technology. And if you come across any problems, once again, it will be much easier for you to solve that as well. And then the popularity as well. Once again, it kind of similar to community. If there's a big popularity, which would mean that there's a bigger community behind that technology. Once again, it'll help you in solving problems and all that. And once again, another thing you have noticed that popularity, where popularity comes into place is when you go to the industry. So in the industry, there are particular technologies that are more in demand compared with others. So if you use one of those technologies when you're building the ITP project that goes to your portfolio, it would be much better. It would increase the chances of being going to the industry as well. So keep that in mind as well, although it's not as important as other important things such as deadlines and requirements. Keep that in mind as well. Okay, then that's it for factors to consider, and these are some of some pointers when it comes to choosing a stack. Now, keep in mind that these are some of the, not all the guidelines that you should follow. There are a lot of factors you should consider, as I mentioned earlier. And what I would suggest you do when you choose a framework is you do some research on your own based on what your requirements are. There are a lot of resources out there in the internet which you can refer to when it comes to choosing a web framework. For example, I show you one here. You have this website, this particular website, which gives you an introduction basically to some front-end frameworks. It describes the pros and cons of that particular technology. In this case, it's React, and when to use it and when not to use. And then Angular, once again, pros and cons, Vue.js. So yeah, I would suggest you do some research on your own in accordance to your requirements. And then you have this website, this particular website as well. I'll be one of the members of MS Club will be posting all these links on chat as well, so you can refer to it. So yeah, here as well you can see some of the technologies. In this case here, Django and the advantages, features of it, and when to use it and when to not. So yeah, what if I would suggest personally is you look into all these pros and cons, and then you should go about and the other factors as well, as I mentioned, these factors, and then you should go about choosing the best framework or the library and the whole technology stack for your project. Okay, so that's it for choosing a technology stack. Yeah, and then I'll be coming to SQL versus NoSQL. So as I mentioned earlier, you for the data storing part, the data storage part of your web application, you will have to use a database technology. And when it comes to database technologies, SQL, I'm probably sure you've heard of it because I think you've followed the ISD module, which contains a lot of SQL scripting and all that, query languaging. So, and there's this new term, and NoSQL I'll be coming to a bit later. So yeah, first of all, SQL basically stands for Structured Query Language. I'm pretty sure that you guys know about this. So it's basically a standardized programming language. It's kind of a programming language. You could call it a query language as well. It has its own syntax and it has variables and all that, much similar to a programming language. And this particular language is used to manage relational databases. I'm pretty sure you've also heard of the term relational databases as well. And once again, it is used for storing, manipulating, and retrieving data in relational databases. So yeah, I'm pretty sure you don't have that much of concern about what SQL means, but NoSQL on the other hand it's quite of a might be quite a new concept for you. It stands for not only SQL, so it isn't a query language or a programming language like SQL. It's more of a paradigm. What that means is it's more of a model of storing data, much like databases. So what NoSQL database does is it stores data in JSON documents or graphs or on formats which are much more different compared to relational database. It doesn't store data in the tables which you are familiar with, with tables with columns and rows. It stores the data on as I mentioned in JSON documents, which is a way of transmitting objects, data objects in web applications. So technologies or the ways through which NoSQL database data is stored is, as you can see, as documents, databases, key value databases, and white column stores and graph databases. I'll come to what that means in a while. So yeah, these are once again the differences between SQL and NoSQL. You have relational databases. So SQL are basically relational databases, while on the other hand, NoSQL are non-relational, which means it doesn't follow the usual column row structure, the table structure which you are familiar with when using ISDM module. And SQL is table-based, as you know, as I mentioned, and NoSQL once again is document or graph-based. And one thing you should notice that SQL is much more suited for complex queries with a much more complex relationship between each tables and all that. While NoSQL, it's not very suitable for databases or applications or projects with much more complex relationships. Keep that in mind as well when you're choosing your database system. And when it comes to examples for SQL, you have MySQL, MariaDB, SQLite, and Postgre. And on the other hand, for NoSQL, you have MongoDB, which you've heard of while earlier from the main stack, and you have Cosmos DB, Redis, and Cassandra. So one misconception people have is that NoSQL databases cannot store non-relational data. It actually can, but it stores relational data in a way which is quite different from the way SQL language stores data. So keep that in mind as well. So here's basically the difference between the two database models. And from on the left side, you can see the relations that you're familiar with, the rows and columns type of storing data. And while on the other hand, on the right side, you can see the NoSQL format, the key value pair, and you have the key and documents. This structure is called JSON format. Yeah, this is how NoSQL databases store your data. So yeah, so I hope you got an understanding about what SQL and NoSQL means and differences between the two. So yeah, that is the end of my presentation. Actually, I hope you guys learned something new, learned something insightful, and I do hope you noted all the factors and all that when choosing a web framework and technologies now. So you could use that. I would suggest once again to do your own research when choosing a technology stack. So once again, thank you, and very best of luck with your ITP project.
And I would love to thank our Dasun as well for the amazing session about frameworks.